So this question asks you to implement a stack using queues. So we'll start off by describing what the difference is between a stack and a queue. So with the queue, you'll commonly hear the term FIFO. This means first in, first out. And what that means is the first element that was added will be the first one removed. So you can picture this as like waiting on a line. Let's pretend this is the entrance. This is the first person to arrive. This is the second person to arrive. This person's the third, and this person's the fourth. Which one's going to be let in first? The one who arrived first. And then the next person who arrived right after that, and so on and so forth. Let's move over to a stack. Stack is just the opposite. It's LIFO, so last in, first out. So with this one, you can picture a stack of dishes. So these are just, let's say, 4 plates stacked on top of one another. Which one are you going to take first? You're going to take the one at the top. Then you're going to take the next one that's at the top, next one, and the next one. All right, so just to demonstrate that to you in another way, this is the queue over here. First element's added, second element's added, third element's added. Which one's going to be removed first? The number 1. Which one's next? The number 2. Which one's next? The number 3. Move over to a stack. Number 1's added first, then number 2, then number 3. Which one will be removed first? Sorry about that. The number 3, followed by the number 2, and then the number 1. So the question is, how do we implement a stack using only queues? There are actually a couple different methods we can use to do this, and 2 of them at least involve using 2 different queues. But this video will focus only on the method that uses 1 queue. The other 2 methods, by the way, I have also made videos for, and I've linked them down below. So how do we do it using only 1 queue? So right now, let's say we have a queue with the letters A and B in it. And let's say I add the letter C. If this were a stack and I wanted to remove something, the letter C would be removed. But since this is a queue, the letter A would be removed. So how do we instead remove the letter C? So what we can do is first take note of how many elements there were in the queue originally. There were 2. This is the number of times we need to rotate this queue. Let me show you what I mean. Right now we have this queue that has A, B, C. What we need to do is rotate the queue to ensure that the letter C is at the bottom. So since the original size was 2, we need to rotate it 2 times. So this will look like this. You remove the letter A, so now the queue becomes B followed by C, and then you add the A back on top. 1 rotation down. So the next rotation, you do the same thing again. Remove the bottom element, so now you have C, A, and then you add the B that was just removed to the top. So remember how we had to remove the letter C? Look what's at the bottom, the letter C. So when you remove it, it's imitating a stack. So before we begin coding, I just want to quickly go over what LeetCode has provided us. So as you can see, there's a myStack class, and it has all the methods that it wants us to implement. So here's the push method. Pushing to a stack just adds an element to the top of the stack. Popping from a stack just removes the top element of the stack. Top just shows the element at the top of the stack, and empty returns whether or not the stack is empty. But what I've gone ahead and done is added a queue class. And I won't go over all the implementation details of this because that's not what this video is about. Just know that all code in this video is linked in the description below. But we have a peek method, and that shows us what's at the bottom of the queue. A size method returns how many elements are in it. Is empty returns whether or not the queue is empty. DQ removes the bottom element of the queue, and InQueue adds an element to the top of it. All right, so let's start coding this out. So remember, we're only going to use 1 queue for this. So this dot queue equals a new queue. For the push method, the goal is to get the element that we're adding to the bottom of the queue. Because remember that when you have a queue and you try to remove an element, it always removes what's at the bottom. So to mimic a stack, which always takes the last element added, we need to get that last element added to the bottom of the stack. So we do this by adding it to the queue, keeping track of what the original size was, because that is the number of rotations that we have to do. So if the original size was 2 elements, we need to rotate the queue twice in order to get the element that we're adding to the bottom of the queue. So let rotations equals this.queue.size. So get the original size of the queue. Then we need to add the element to the queue. In queue just means add. And we're adding this element, x. So while rotations are greater than 0, this.queue.inQueue, this.queue.dQ, and then rotations minus minus. So what this does is, let's say we start off needing to rotate the array twice. Rotations would be 2. And then what it does is it takes out the bottom element of the queue and moves it to the top. So now we have 1 rotation to go. So we'll do the same thing again. So we take out the last element of the queue and move it to the top. So now the element that we just added would be at the bottom of the queue, which is where we need it to be. Okay, so then the rest of these methods are just easy. So to pop, all we need to do is remove the bottom element in the queue. So return this.queue, .dq. Top is we're just going to return this.queue.peak. When we're peaking, all we're doing is checking the bottom element. We're not removing it, we're just checking it and returning it. And then empty, we're returning this.queue.isEmpty, which just checks whether or not it's empty. All right, so let's try it out. Seems to work. Submit it. There we go. Faster than 16% of online submissions. This has varied between, 15% to 40%. So just depends on when you submit it. So, all right, see you next time.